Hello and welcome in Teach Max videos. I am Sajjan Wag. I am going to teach you Structural Analysis 1. So we know this subject is for second year second semester for civil engineering students, okay, under SPPU. Okay, so we know unit number 1 of Structural Analysis 1, that is fundamentals of structures, slope and deflection of beams and frames. Okay, so this unit I am going to divide into 3 parts, okay, A, B, C. Part A is totally related with the fundamentals of structure, part B totally related with the slope and deflection of beams by using geometric methods, in which we are going to find out slope and deflection by using Macaulay method, movement area method and conjugate beam method. And in C part of this unit we are going to find out again slope and deflection of beams and frames by using conjugate beam method, strain energy method. Okay, so this is the content. Okay, so let us see one by one. So this is the syllabus. In A part we are going to focus on type and fundamentals of structures, means exactly what is the structure, what are the type of structure, classification of structures based on structural form, structural actions, structural system, then concept of stability, what is force, what are the internal forces developed in the structure, then what are the displacements developed in the structure, so that we are going to discuss. Then we are going to focus on concept of indeterminacy for static as well as for kinematic. So we are going to find out static degree of indeterminacy and kinematic degree of indeterminacy, because this is the first step for the analysis. Okay, so for the analysis of indeterminate structures we need to understand what are the type of structures and its classification, and of course static and kinematic degree of indeterminacy. So that we are going to focus in A part of this unit. In B part we are going to focus on slope and deflection of beams, as I said, by using geometric methods, and they are Macaulay method, movement area method, it is also called as Morse method, and conjugate beam method. This method is developed by Mueller-Breslau. So we can say this is conjugate beam method. So almost 3 methods. By using 3 methods we are going to find out again slope and deflection of beams, okay, for determinate structures, and of course its applications we are going to see. And in C part of this unit we are going to focus on again slope and deflection of determinate beams and frames by using energy method. Okay, so all these 4 methods we are going to study in this. This unit is very vast. Pay attention for this. It is asked for online examination almost for 13 marks and for theory examination for 6 marks. Okay, so and of course pattern 2015. Okay, let us go with the A part, fundamentals of structure. In this we are going to first of all see assumptions. What are the assumptions we are going to take or we are going to consider for the analysis, structural analysis? Then what is mean by structure, what is mean by structural analysis, what are the key points in it? Then internal forces, internal displacement, or internal forces and possible displacements, because it is totally, these 2 keywords are very important for structural analysis point of view. Then sign conventions that we are going to see throughout SA1, which are the sign conventions we are going to use, so that we are going to discuss. And then classification of structure based on structural form, structural action, structural system, because we are dealing with structural analysis subject, so we need to classify the structure for the structural analysis point of view, so that we are going to see. Then stability of the structure, then concept of indeterminacy. Okay, in that static, kinematic, indeterminacy we are going to see, and we are going to solve some numericals, examples for the beams, frames, right, for static and kinematic indeterminacy. And later words we are going to see some MCQs, multiple choice of questions based on this whole part. Okay, so I'm sure that you are going to enjoy this whole video. Okay, and if you go through it, definitely you will score in this subject. Okay, so let us start with this. Assumptions used in structural analysis. What are the assumptions we are going to consider in structural analysis? This is very important, right, because many principles are depends on these assumptions, right? So let us see one by one. Okay, a structure or a body is assumed to be elastic. Means what exactly? Here, each and every material which are used to prepare to made up the structure, this material, for that material we can draw a stress strain curve diagram, right? We can test and we can draw a stress strain curve diagram. So we get some proportional limit, right? Stress is proportional to strain. So we get a linear curve. So up to linear curve, the behavior of the material we are going to consider. Okay, up to elastic point we can say. It obeys Hooke's law definitely. So whatever be the structures available, that we are going to assume perfectly elastic. Okay, practically we know no any body or no any structure is no any body or material which is perfectly rigid, perfectly elastic, right? So for each and every material, if you draw a stress strain curve, we get some graph, some linear proportion, some non-linear proportion. But to understand, we are going to consider the linear behavior of the structure. So up to that much point. So that's why we are assuming each and every structure or a body is perfectly elastic, right? Okay, let us go to next assumption. This is also very important assumption. A body is assumed to be homogeneous. All these assumptions already we use in strength of material, same we are carried for this subject for structural analysis. Okay, so a body is homogeneous means what? It means the properties, identical properties in identical direction. The body has identical properties in identical direction is same. Means exactly you can say that if a body has identical property in identical direction at all points, very important, at all points, then we say it is a homogeneous. And next assumption is also very important, that the body assumed to be isotropic. Isotropic means, again, it is related with the properties. The identical properties in all direction at a point is same. So almost we can say it is known as isotropic. Fine. So I hope you understand these two. And next one, the body is assumed to be solid continuous structure. So it is made up by number of particles that we are going to assume. So it is assumed as a solid continuous structure. And the last and very important, as I said, the principle, there are many methods or principles which are totally based on the assumptions. Okay, so the principle of superposition only and only valid if we consider the linear behavior of the structure, right? So this is very important. So here principle of superposition is valid. What is principle of superposition? That you must know. Okay, the two, if a system or if a body subjected to suppose two forces which develop some deflection, right? So if you want to find out the deflection at any point in the body, you can consider these two forces separately and you can find out the displacement or deflection separately. And if you add these two together to different or individual effects, if you combine together, definitely you will get the exact total deflection. So that is delta 1 plus 2 is equal to delta 1 plus delta 2. So two effects you can consider separately. N number of four causes you can consider separately, and if you combine together you will get the same result what you want. Okay, so that is principle of superposition. Okay, it is only and only valid if material is perfectly elastic. So throughout structural analysis, here this principle is valid, so that we are going to use. So I hope you understand some these assumptions. Okay, of course here one assumption is missing in this, that the plane section before bending remains plane even after bending. So this assumption is also we are going to consider, in which the strain is of course linear about the neutral axis we can say, or it is neglected. So horizontal shear strain is neglected. So like this way you can say. So these are the almost some assumptions that we are going to use throughout structural analysis 1. I hope you understand this. So let us move to next part. What is the structure? What is mean by structure? Right? So if you look here and there, everywhere there is a structure, right? So each and every material or body which is made up by number of particles, right? So each and every body, if you combine together, or each and every member if combined together at the joints, right? There are some joints provided at the, if you connect two bodies or two particles, two members we can say, right? So it is connected at the joint or supports, and it is used to carry the load. Okay, the best example is human body. Human body is also one of the great example of structure, right? So each and every part is having some function, right? So each and every part we can say as a structure. Okay, so it is a definitely it is a construction built to a particular form, right? And it consists of number of members, number of joints, right, which is used to carry the external loading and transfer safely into the sub member or indirectly transfer into the ground. Okay, so this is the definition of structure. So we can easily remember this. This is it. A structure is any construction built of a particular shape, consist of members, joints and supports to resist external loading and transfer these external load safely into the ground or sub member is nothing but a structure. The best example we can say human body, buildings, bridges, dams, whatever you are going to see here and there, for that is nothing but structure. So in civil engineering we know the structures, building, dams, etc. All these are the structures, right? So this is structure. Fine. So we are going to analyze it, means we are going to find out exactly, we are going to see the internal as well as exterior behavior, internal as well as external behavior of the body when it is subjected to external load, right? So that is structural analysis, actually, to study and determine internal forces mainly and displacements, means internal behavior and external behavior, okay, of all members, joints and supports while carrying the external loads, right? So this is structural analysis, right? So structural analysis and structural design. So as I explained in previous lecture, promotional lecture, right? So structural analysis and structural design, we know structural, there are two parts in the structural design. One is, of course, the first part is structural analysis and second part is structural डिजाइन. तो यहाँ पे ऐसा नहीं है कि मुर्गी फर्स्ट या अंडा फर्स्ट. नो, हियर डेफिनेटली स्ट्रक्चरल एनालिसिस इज द फर्स्ट पार्ट before going to structural design. So whatever be the internal forces develop in each and every member, that we must find out first, and its behavior also we study first. Then and then only we can give the dimensions to each and every member, right? So that is the design part. Okay, so analysis is the first part or first step for the design, my friends. Okay, so remember these all. Okay, so let us move to next. So now you understand exactly what is structure and what is structural analysis. The key word for the structural analysis is very important: internal forces and displacement. So these two words throughout structural analysis we are going to remember, and we are going to find out these all. Okay, both, that is internal forces and displacements. Okay, so what are the internal forces? See, each and every structure we need to idealize it into a plane, into a space, depends on the analysis point of view, right? So how we can simplify this analysis? Okay, so for that we can convert a whole structure into a simplified form or simplified way for the structural analysis. So we can idealize the structure into a plane. That structures are called as plane structure, that we are going to see after this slide. Also, if you consider whole structure, definitely it is in space or 3 dimensions, so we need to understand that also, right? So behavior, to study the internal as well as external behavior, first of all we need to understand what type of structure we are going to assume, right? So here, what are the internal forces developed for each and every type of structure? So that we are going to see here. Okay, so we can categorize or idealize the structure into 2 parts mainly, okay, for analysis point of view, and here we only analyze skeleton structures. Okay, so that we are going to see later words what are the type of structure, but here you can remember that we are analyzing only skeleton structure in this UG course. Okay, so skeleton structures also divided into 2 parts. One is If you consider that skeleton structure in one plane, it is called as plane skeleton structure, or we can say one-dimensional structures. And if you consider that structures in all three directions, skeleton structures in all three directions, they are called as space skeleton structures. So we are going to analyze these two type of structures, right? So see this. Okay, so what are the internal forces developed in these skeleton structures? Okay, for plane structure, first of all, for space structure, skeleton space structure, there are 6 internal forces developed when the load acting over the structure. So which are they? See this, P. The first one is P. P means what? P means the axial force. P is nothing but the axial force. Of course, it is along the longitudinal axis of the member, right? Vx is the shear force along centroidal axis, right? Along x direction, let us consider. I am considering x and y are the centroidal axis, cross-sectional axis, and z is the longitudinal axis. So, Vx, here it is. So, Vx is shear along x direction, P axial force, it is along longitudinal direction. Then Vy is vertical shear, so that we already find out for the beams, right? So axial force, shear, these are shear along x and y, these are the forces which are generally developed internally into member, okay? And mx and my, these are the two bending moments which are developed, okay? So here it is, my is there and mx is there. So these two are the bending moments which are developed about the cross-sectional axis, we can say, and mz is the twisting moment generally developed about longitudinal axis. So we can say, so almost there are six internal forces, internal force components which are developed in the structure. Okay, so this is for skeleton space structure. Remember this. Okay, so here just understand this automatically. When you are going to find out the static and kinematic indeterminacy, and when we are going to analyze the structure, you can easily remember these all, okay, and you can easily understand everything. Okay, so next, for skeleton plane structures. So if you consider a whole structure into a single plane, okay, if you idealize the structure into a single plane, for example, beams, rigid jointed frames, pin jointed frames, we can analyze in plane, in single plane as well as in space also. Okay, so that we will see later. Okay, so here just understand this, the skeleton plane structures, definitely it is in one plane. So here out of these 6 internal forces, only 3 internal forces which are predominant, we can say, than other. Okay, so because loading is also in the same plane for the plane structure. So P, V and M, axial force, shear force and bending moment, these are the 3 internal forces generally developed for the plane skeleton structure or skeletal structures. Fine. So this is about the internal forces. Let us move to next, displacement. So which are the displacements? Because these two keywords are very important. Internally we understand which are the internal forces developed, right? Now let us see displacement. So displacements means it is totally related with the exterior or external behavior of the structure. So for skeleton space structure, 6 possible displacement components are there. Which are they? UVW. What is this UVW? UVW is nothing but the translation along x, y and z direction. See, displacement we can divide into 2 parts. One is translation and second is rotation. So displacement means translation as well as rotation. Translation, we know, if without rotating the body is in motion in only one direction, its rotation we neglect. So of course it become a translation, we can say it is a translation. So that we studied the difference between rotation and translation in engineering mechanics, right? So UVW are the translation along x, y and z direction. You can denote by x, y, z also. Okay, so all these U, V, W. Okay, so these all three are translations. Theta x, theta y, theta z. These are all rotations about x, y and z axis respectively. So this is for skeleton space structure. These are the possible displacements for the skeleton space structure. Okay, you can say. And what are the possible displacements for the skeleton plane structures? Here we go. It is U, V and theta x. Only. Okay, just like PVM, possible internal forces for the plane skeleton structure, UV theta x, it is for plane structures. Again, these are the possible displacements. So only we are dealing with these two. Okay, means we are going to analyze throughout our UG course plane skeleton structure, not space skeleton structure. This is just, if you understand plane skeleton structure, you can easily analyze space skeleton structure, because in space skeleton structure only the number of internal forces and external external displacements are increased. That's it. The concepts are same, procedure is same, almost each and every method is same. Only in plane structure, first of all we need to analyze simple, right? जैसे सेकेंड स्टैंडर्ड से पहले हम फर्स्ट स्टैंडर्ड में पढ़ते हैं वैसे है, तो पहले हमें फर्स्ट स्टैंडर्ड पढ़ना है, यूजी कोर्स. इन यूजी कोर्सेस वी आर गोइंग टू डील विद द plane structures, right? So I hope you understand. Let us move to sign conventions throughout structural analysis 1. Which are the sign conventions that we are going to use, right? So related with the end forces throughout this subject, right? What are the sign convention I am going to use that we are going to see here? Okay, so let us see first one, end forces and displacements. End forces and displacement. Upward, see first one, upward any term, may be force, may be displacement. If it is going up, rightward and anti-clockwise, we take positive. Okay, positive end forces and displacement. It is totally related with end forces and displacement. Okay, and sign conventions, if you consider, if any term going down, leftward and clockwise, we considered negative, right? So like this way, end forces and displacements we considered. So these are the sign conventions that we are going to use. Fine. So I hope you understand. What about the axial forces? Axial tension we are going to consider positive, axial compression we are going to consider negative. So positive for axial tension and negative for axial compression. Pull positive, push negative, right? What about the shear forces? As already we see, we use these sign conventions in strength of material also. Same sign conventions we are going to use in this subject also, because it is almost same, right? So already I differ the what is strength of material, engineering mechanics, structural analysis and structural design in my previous video, right? That is preview or overview of the structural subject, so that we discuss in the first video, right? So let us, same sign convention we are going to use here also for shear force, right? So positive shear force means what? Clockwise. Generally at a section, right, if you take a section for right part, what is shear force? First of all you need to understand a tangential force. Remember, it is the force which is tangential to the cross section that is called as shear force. If you take the sum of these tangential forces for beam is generally horizontal, so that's why we take summation of vertical forces, indirectly shear force we get, right? So here if you consider the left part, upward force we consider positive and downward force we consider negative for left part. If you take the sum of right part at a section, right part of the beam, so definitely downward become positive and upward become negative, ulta. Okay, तो लेफ्ट पार्ट को रेगुलर साइन कन्वेंशन, अपवर्ड पॉजिटिव डाउनवर्ड नेगेटिव. अगर राइट पार्ट है तो डाउनवर्ड पॉजिटिव लेना है और अपवर्ड नेगेटिव लेना है. So these are the sign conventions that we are going to use for the shear force, right? So let us move to next, bending moment now. So natural bending, we say sagging, opposite to it hogging. Natural means generally load downward hota hai, bend niche hoga, sag we say, okay. Sagging, so sagging is develop, and sagging movement means natural bending movement and it is going down, so we consider it is positive, and hogging movement we considered negative. So generally a simply supported or any beam other than cantilever beam, when it is loaded vertically downward, it bent downward, so we say it is sagging movement. So we draw BMD on positive sign, positive direction, right? So above the baseline, okay. And cantilever beam is the best example. When it is subjected to external load, it bent down and it is in hogging in nature. So there we say, for cantilever beam we draw the BMD below the baseline, right? So that we draw already for statically determinate beam. So that is prerequisite for structural analysis subject. You must able to draw shear force and bending moment diagrams for statically determinate beams particularly, okay, once you know the reactions at the supports, okay. So same concepts we are going to use for structural analysis 1-2 subjects, right? So bending moment, understand? So if you consider, if you take a section at the middle, here it is mentioned, for left part clockwise is positive, anti-clockwise is negative. If you take a movement of right part at a section, definitely clockwise is negative and anti-clockwise is positive. So that you must know, right? So these are the standard sign conventions that we are going to use. So remember these all. Fine. Let us see next point. Classification of structure. This is very, very important form, a very, very important topic we can say for examination point of view as well as understanding point of view, of understanding of this subject, okay, structural analysis, structural subjects we can say. Okay, so see, we can classify the structure already in basic civil engineering. We classify the structure based, पहला ही पॉइंट था है ना, क्लासिफिकेशन ऑफ स्ट्रक्चर बेस्ड ऑन द लोड ट्रांसफर फिनोमिना, ओके, लोड ऑफ द स्लैब ट्रांसफर इनटू द wall, okay. So wall carry the loads, that structures we say it is a load bearing structure, right? And we class, and the second category is frame structure, load of the slab if it is carried by the beams, beams carry their load and transfer into the columns, column transfer into the adjacent column, and finally it is into the ground. So that structures are called as frame structures. So that we study already, and that is the classification based on load transfer phenomena, right? But structural point of view, if you want to classify, also you can classify the structure based on material, right? Steel structure, RCC structure, pre-stressed structure, precast structures, hybrid structures, right? Composite structures. So all these are the classification based on the materials provided, right? Now we are going to classify the structure based on structural point of view. So structural form means what? If you want to analyze or design any building, okay, for design any structure, not building, any structure, we need to think about in each and every member, each and every joint, each and every support, right? So we need to idealize, discretize the whole structure into a parts for the analysis. तो ये है discretization, okay. तो यहाँ पे हर एक को अगर अलग ट्रीटमेंट और अलग वे से हमने देखा तो हम सेपरेट करके कर सकते हैं. तो discretization, so very important to understand this, that we specifically, for the simplicity, the structures are analyzed by simple discretization. So here we idealize the whole structure into a different planes, okay. So if you idealize the structure in one plane, in some of the cases what happen, load is in one plane as well as structure is in one plane. Best example, beams. Load is vertical generally, beam is horizontal, so it is in one plane, so you can easily idealize the structure into one plane. Plane trusses, plane rigid jointed frame, if you consider loading is in one plane, of course they are also in one plane, so we can simplify into a one plane. Similarly, if you consider the structures in all three direction, in two direction, so we can say it is plane structure or surface structure. If you consider in three dimension, it is mass structure. So like this way, you can idealize the structure, depends on the requirement or based on the simplicity of the analysis. So first of all, we are going to classify the structure based on structural form. Okay, so very first of all, we are going to classify the structure based on structural form, structural geometry. Remember, okay. So what is it? This is it. Okay. So first we are going to categorize into discrete or framed or skeleton or skeletal structures. Okay. So we can discretize the structure into one. Okay. That is discrete. तो ये तीन फॉर्म हो सकते हैं स्ट्रक्चरल फॉर्म. अगर आपको स्ट्रक्चरल फॉर्म में स्ट्रक्चर क्लासिफाई करना हो तो एक डिस्क्रीट फ्रेम और स्केलेटन स्ट्रक्चर और दूसरा कंटिन्यूम स्ट्रक्चर. ओके. और तीसरा कंबाइंड हाइब्रिड स्ट्रक्चर. ओके. सो दिस इज द क्लासिफिकेशन वी कैन से. ओके. तो डिस्क्रीट और फ्रेम और स्केलेटन स्ट्रक्चर मीन्स व्हाट? इफ यू कंसीडर, इफ यू रिमूव द non-structural elements from the structure. From the structure, there are two type of elements in the structure. One is structural elements and second is non-structural. Means those who carry the load, we say it is a structural elements, and those who not carry the load, we say it is non-structural elements. So if you idealize or discretize the structure into a only load carrying structures, members, so we can say it is discretization. Okay. So if that all are in one plane, okay, if that all members, if you consider straight lines, okay, if some of the members are generally straight or linear, we can say, and also we can say they are curvilinear, they are in, okay, so both type of structure, so that all comes under this discrete or frame or skeleton structure. जैसे हमारे ह्यूमन बॉडी से मसल्स मास अगर निकाल दिया तो क्या बचेगा? स्केलेटल बचेगा, स्केलेटन बचेगा. सो दैट इज अ स्ट्रक्चर. ओके. बिकॉज द होल लोड ऑफ द बॉडी इज कैरिड बाय स्केलेटल ओनली. ओके. सो वैसे सेम स्ट्रक्चर को तो उसे आप कहोगे डिस्क्रीट और फ्रेम और स्केलेटन स्ट्रक्चर. प्लेन एंड स्पेस स्केलेटल स्ट्रक्चर. ओके. तो दोनों है इसमें, ऐसा नहीं कि एक ही है. अगर एक प्लेन में कंसीडर किया तो उसे प्लेन स्केलेटल स्ट्रक्चर कहोगे. अगर उसे थ्री डायमेंशन में कंसीडर किया तो उसे स्पेस स्केलेटन स्ट्रक्चर कहोगे. राइट. ओके. वैसे कंटिन्यूम स्ट्रक्चर्स, व्हाट आर दे? सॉलिड स्ट्रक्चर, सरफेस स्ट्रक्चर्स, मीन्स टू डायमेंशनल, थ्री डायमेंशनल स्ट्रक्चर्स कम्स अंडर दिस. क्या है 1D, 2D, 3D? वन डायमेंशनल मीन्स skeletal structure, whose, if you consider one member whose length is very very large compared to cross sectional dimension, so we say it is one dimensional structure. So we can categorize into 1D. So skeleton structures comes under this. Okay. plane B और space B one dimensional. और दूसरा जो continuum structure है उसमें surface solid means two dimensions are very large, predominant than the third dimension. Best example, plate, shell, dome, grid, slab. So all these are the example of surface or solid structure. Also continuum structures we can categorize into 3D also. Okay. 2D and 3D comes under continuum structures only. तो two dimensional अभी मैंने बोला plane, skeleton, plate, slab, right, grid slab. So all these comes under plane or surface structure. उसके दो डायमेंशन बड़े हैं कंपेयर विथ थर्ड डायमेंशन. सिमिलरली तीसरा 3 डायमेंशन कौन से? जिसके तीनों डायमेंशन प्रिडोमिनेंट है और तीनों कंसिडर करने पड़ेंगे एनालिसिस पॉइंट ऑफ व्यू. सो हियर इट इज बेस्ट एग्जांपल डैम्स, रिटेनिंग वॉल, फुटिंग्स. All 3 dimensions are predominant, so we need to consider all 3, right? So 3 dimensions. And the last is combined or hybrid structure. The examples are there: stiffened plate bridge deck, stiffened plates, bridge decks, and beam slab system. If in RCC we know beam and slab, they casted together, so definitely we can say it is a hybrid structure. Combine two members, two structures, if you combine together, we can say it is a combined or hybrid structure. So Here it is. This is the classification based on structural form. So I hope you understand this. तो यहाँ पे एक्चुअली स्ट्रक्चरल एनालिसिस में हम क्या पढ़ते हैं? हम जो एनालिसिस कर रहे हैं यूजी कोर्स में वो है वन डायमेंशनल प्लेन स्ट्रक्चर. ओके, स्पेस भी नहीं कर रहे. तो वन, अगर प्लेन समझ में आया तो स्पेस आएगा, ऐसा समझ लिया है हमने. ठीक है, अब आगे जाते हैं. 2D कब करेंगे? स्लैब्स, प्लेट्स, शेल्स, डोम्स, ग्रिड स्लैब्स, ये पीजी कोर्स में है. अगर आप पोस्ट ग्रेजुएशन स्ट्रक्चरल इंजीनियरिंग में करना चाहते हो, करोगे तो डेफिनेटली यू आर कम टू अक्रॉस दीज ऑल. ओके, सो दैट दीज स्ट्रक्चर्स वी आर गोइंग टू एनालाइज इन मास्टर सब्जेक्ट्स. ओके, एंड 3D, 3 dimensional structures whose analysis and design, some we are going to study now in UG course and some are in PG courses. Okay, so this is it. So retaining wall यहाँ पे करने वाले, footing यहाँ पे करने वाले, right? Dams का एनालिसिस ऑलरेडी स्ट्रक्चर एनालिसिस 1 में, सॉरी, स्ट्रेंथ ऑफ मटेरियल में आपने किया. डायरेक्ट स्ट्रेसेस, कंबाइंड स्ट्रेसेस फाइंड आउट किए, राइट? तो कुछ पार्ट यूजी को है, रिमेनिंग जो एडवांस पार्ट है वो पीजी को है. फाइन. सो हियर वी अंडरस्टैंड ईच एंड एवरीथिंग. ऑफ कोर्स कंबाइंड स्ट्रक्चर आर आल्सो वी आर गोइंग टू एनालाइज इन पीजी, राइट? सो जो मैंने अभी बोला था उसका ये फिगर है, राइट? तो स्केलेटन स्ट्रक्चर्स कौन कौन से होंगे? बीम्स, फ्रेम्स, पिन जॉइंटेड फ्रेम्स, आर्चेस हुज वन लेंथ इज वेरी वेरी लार्ज. लेंथ इज वेरी वेरी लार्ज देन द क्रॉस सेक्शनल डायमेंशन, राइट? ओके, तो इसे कहेंगे आप. तो बीम, रिजिड जॉइंटेड फ्रेम, ये एक प्लेन में है. पिन जॉइंटेड फ्रेम एक प्लेन में है, तो इसे आप कहोगे वन डायमेंशनल प्लेन स्केलेटन स्ट्रक्चर. ये सब प्लेन स्केलेटन स्ट्रक्चर है. आर्च, केबल्स, है ना? तो ये सब. और ये है हाइब्रिड स्ट्रक्चर्स, सॉरी, कंबाइंड 2 dimensional, no, not combined, it is 2 dimensional continuum structures. Plates, domes or shells, slabs and grid beams, we can say. Grid beams, generally the beams are crossed to each other, okay, and it form a grid. Okay, if beams are crossed to each other in one plane, okay, if you, this is the plan, we can say. Generally these beams are provided in corridors of public building for aesthetical point of view. So these are the grid beams. So we can say these are 2 dimensional because 2 dimensions are, so whole we combine together. So that's why we consider whole as a structure, not a single beam. Okay, so that's why grid beam. And 3 dimensional walls are there, dams are there, foundations are there. So this is it. Fine. Now skeleton structure, as I said, we classify into two. One is plain skeleton structure and second is space skeleton structure. तो इसमें भी दो है, rigid jointed frames, pin jointed frames. Rigid jointed जो RCC में आप कह सकते हो या somewhat स्टील में भी कह सकते हो. तो रिजिड जॉइंटेड फ्रेम में भी दो है, वन इज प्लेन फ्रेम्स और दूसरा है स्पेस फ्रेम. ओके, तो बेस्ट एग्जांपल फॉर रिजिड जॉइंटेड प्लेन फ्रेम आरसीसी का कोई भी एक कॉम्बिनेशन ऑफ बीम एंड कॉलम, इफ यू कंसिडर इन वन प्लेन, सिंगल बे सिंगल स्टोरी, इट इज नथिंग बट बेस्ट एग्जांपल फॉर प्लेन फ्रेम. ओके, स्पेस फ्रेम अगर वो 3 dimension में कंसिडर किया, मल्टी बे मल्टी स्टोरी इन बोथ द डायरेक्शन, सो वी से इट इज अ स्पेस रिजिड जॉइंटेड फ्रेम. आरसीसी में बिल्डिंग का, पूरे बिल्डिंग का अगर आपने तीनों डायरेक्शन में फोर्सेस मेंबर्स कंसिडर किए, बीम एंड कॉलम, सो इट बिकम स्पेस फ्रेम. प्लेन ट्रसेस, प्लेन ट्रसेस कहां पे आते हैं? प्लेन ट्रसेस वी प्रोवाइड इन वेयर हाउसेस, गोडाउन्स, इंडस्ट्रियल बिल्डिंग्स एक्सेट्रा. Loading is in one plane, load of the roof carried by the trusses, right? So that members are, that whole structure is nothing but the pin jointed frame. So remember friends, pin jointed frames are nothing but the trusses. Okay, space trusses कहां पे आते हैं फिर? Towers, right? Petrol pump, over petrol pump, if you see toll plaza, where generally we observe the trusses are in 3 dimensions, right? So space trusses. So these are the figures available with me. Plain trusses, ये है space trusses. Okay, तो ये ऐसे कर सकते हो। प्लेन फ्रेम के लिए एक सिंगल, जैसे मैंने अभी कहा रिजिड जॉइंटेड फ्रेम, एक सिंगल बे सिंगल स्टोरी अगर कंसीडर किया, ये हो गया एक एग्जांपल। मल्टी बे मल्टी स्टोरी भी कर सकते हो, लेकिन एक प्लेन में कंसीडर किया तो। अगर ये स्पेस में करना है आपको तो ये ऐसे आएगा, तो ये ऐसे मिलेगा स्पेस में। ओके, तो उसका तीनों डायरेक्शन में आपको वो फ्रेम कंसीडर करना है। सो दिस इज अबाउट द क्लासिफिकेशन ऑफ स्केलेटन फ्रेम, मतलब पहली कैटेगरी है ये। ठीक है, नाउ आई होप यू अंडरस्टैंड। तो इस पे एग्जामिनेशन पॉइंट ऑफ व्यू जिसके लिए आप देख रहे हो, राइट, तो ये पूछते हैं बीम्स आर क्लासिफाइड एज skeleton structure, surface structure, continuum structure, none of these. So answer is skeleton structure. Rigid jointed frames are classified as skeleton structure. Plates or slabs are classified as. So whole these, all the examples whatever I have given might be asked as a MCQ. Okay, so remember each and everything, right? Now next one. This is it. The classification of structure based on structural actions. What is mean by structural action? If any member, if it is subjected to any load, definitely it having some internal forces. Okay, so based on the internal forces, we classify the structure. Okay, this is the second category or second way to classify the structure, we can say. Okay, so which are they? Some of the structure carry their load by developing axial forces only. उसमें सिर्फ एक्शियल फोर्स आता है, ऐसे स्ट्रक्चर्स हम एक कैटेगरी में कर सकते हैं। दूसरा, स्ट्रक्चर कैरी देयर लोड बाय डेवलपिंग मूवमेंट्स ओनली, सिर्फ मूवमेंट है उसमें। और तीसरा, स्ट्रक्चर्स कैरी देयर लोड बाय डेवलपिंग फोर्सेस एज वेल एज मूवमेंट्स, दोनों, तो उसे हम तीसरी कैटेगरी कह सकते हैं। ठीक है, तो ये सब एग्जांपल है, बीम्स, कॉलम्स, प्लेन। अब देखते हैं वन बाय वन, जो मैंने स्ट्रक्चरल एनालिसिस 1 के पॉइंट ऑफ व्यू है वो सब, या कंबाइन भी है इसमें। देखते हैं बीम्स, स्केलेटन स्ट्रक्चर है, तो उसमें कौन से फोर्सेस आते हैं? ऑलरेडी वी ड्रॉ शेयर फोर्स एंड बेंडिंग मूवमेंट डायग्राम, राइट? सो डेफिनेटली बीम्स कैरी देयर लोड बाय डेवलपिंग शेयर एंड बेंडिंग। एक्शियल फोर्स भी होता है बहुत, लेकिन वो बहुत निग्लिजिबल होता है, बहुत निग्लिजिबल। ठीक है, तो आप वो निग्लेक्ट कर सकते हो। कभी कभी हम शेयर भी निग्लेक्ट करते हैं, जब बेंडिंग ज्यादा हो और शेयर लो हो तो हम शेयर भी निग्लेक्ट करते हैं, शेयर फोर्स। तो बीम्स कैरी देयर लोड बाय डेवलपिंग shear force and bending moment is also more than enough, no need to consider axial forces. Okay, कभी कभी axial force भी डेवलप, प्रिडोमिनेंट नहीं होता, निग्लेक्ट करते ही है हम। ठीक है, कॉलम्स, तो ये कौन से कैटेगरी में आ गया? बीम, दोनों है तो ये थर्ड कैटेगरी में आ गया। तो ज्यादातर थर्ड में ही जाएंगे क्योंकि दोनों होते हैं, फोर्स भी होता है, मूवमेंट भी होता है, इंटरनली डेवलप। तो ऐसे बहुत सारे हैं। कॉलम्स कैरी देयर लोड बाय डेवलपिंग प्योरली एक्सियल कॉम्प्रेशन। कुछ कॉलम में सिर्फ एक्सियल कॉम्प्रेशन ही होगा तो वो जाएंगे, वो जाएंगे फर्स्ट कैटेगरी में, वो जाएंगे फर्स्ट कैटेगरी में। कुछ कॉलम में दोनों होंगे, एक्सियल फोर्स और यूनिएक्सियल लोडिंग, यूनिएक्सियल मूवमेंट, राइट? मूवमेंट अबाउट ओनली वन एक्सिस, इसेंट्रिकली लोडेड कॉलम, राइट? या विंड की वजह से, विंड अगर एक ही डायरेक्शन में है तो वो वैसे भी हो सकता है ना, कॉलम पे, एक्सटीरियर कॉलम पे, तो आप उसे सेकेंड कैटेगरी में डाल सकते हो। ठीक है, पी एंड एम थर्ड कैटेगरी में, सॉरी, क्योंकि एक ये हो गया। और कुछ कॉलम ऐसे भी होते हैं स्ट्रक्चर में कि जिसमें दोनों आएंगे, एक्सियल फोर्स और बाय एक्सियल मूवमेंट भी आ सकता है। तो पी, एम एक्स एंड एम वाई, all three are possible, right? So these are the internal forces developed in the column. What about the plane trusses? Plane trusses carry their load. प्लेन हो, स्पेस ट्रस हो, ट्रस में हर मेंबर में एक ही आता है, एक तो एक्सियल टेंशन या एक्सियल कॉम्प्रेशन। तो ये प्योरली इट कम्स अंडर फर्स्ट कैटेगरी, द स्ट्रक्चर कैरी देयर लोड बाय डेवलपिंग एक्सियल फोर्सेस ओनली। कौन से है? प्लेन ट्रस और स्पेस ट्रस, उसमें सिर्फ एक्सियल फोर्स ही आएगा, पी। एक्सियल टेंशन रहेगा या एक्सियल कॉम्प्रेशन रहेगा, या प्लेन में हो या स्पेस में हो, हर में एक ही आता है ना। तो ये हम एनालिसिस करने भी वाले हैं। प्लेन फ्रेम्स कैरी देयर लोड बाय डेवलपिंग, प्लेन रिजिड जॉइंटेड फ्रेम्स है ये, तो दे कैरी देयर लोड बाय डेवलपिंग एक्सियल फोर्स, शेयर एंड बेंडिंग मूवमेंट, तीनों पीवीएम और एमवीपी यू कैन से। ओके, आर्च कैरी देयर लोड बाय डेवलपिंग, आर्चेस कहां पे प्रोवाइड करते हैं हम? जनरली इन केस ऑफ ब्रिजेस, ओके, वेयर स्पैन इज वेरी लार्ज, लोडिंग इज प्रिडोमिनेंट, okay, so in that case the straight beam is very uneconomical. If you provide a straight beam, it become uneconomical, so we can provide a curved beam. So curved beam is nothing but the arch, and arch carry their load by developing, of course, if you cut it, definitely at any section we get axial thrust and movement, or we can say axial compression and बेंडिंग मूवमेंट. सो दीज टू आर द इंटरनल फोर्सेस. फिर ये एक्सियल कॉम्प्रेशन, एक्सियल थ्रस्ट हम रिजॉल्व करते हैं अलोंग एक्स एंड वाई, तो हमें मिलता है शेयर, रेडियल शेयर, एक्सियल रेडियल शेयर, नॉर्मल थ्रस्ट और मूवमेंट तो है ही. तो एक्सियल कॉम्प्रेशन हम रिजॉल्व करते हैं नॉर्मल डायरेक्शन में और टेंजेंशियल डायरेक्शन में, तो हमें एक्सियल थ्रस्ट और रेडियल शेयर मिलता है. तो वो हम एनालिसिस करने वाले हैं यूनिट नंबर 5 में. ओके, सो यूनिट नंबर 5 इज टोटली वी आर डीलिंग विद द आर्चेस. ओके, cables carry their load by developing. Cables we know, we already analyzed it. They are provided generally in suspension bridge. Cables carry their load by developing axial tension. So it comes under first category. They carry their load only by developing axial tension. Compression भी नहीं आएगा इसमें. ठीक है. Two-way grid carry their load by developing. क्या होगा two-way grid में? Two-way grid में एक तो bending movement आएगा और twisting movement भी आएगा. दोनों movements आएंगे. Bending movement as well as twisting movement. So both. And thin plates carry their load by developing bending. Okay, इसमें भी दोनों movement and both movements, right? So I hope you understand these all 8, because these are also might be asked as MCQ like this way. Plane trusses, the members in the plane trusses carry their load by developing. Option A, axial forces only. Option B, axial forces and bending moment. Option C, both. Option D, none of these. So like this way. So for any type of truss, members carry their load by developing axial forces only. So कोई भी पूछ सकते हैं, तो पूरा आपको करना ही है. So I hope you understand this. This is the classification based on structural action. Okay, internal forces. Right, let us move to next now. The classification of structure based on structural system. Okay, so structural system, already we classify these in engineering mechanics, right? Structural system, statically determinate structure, statically indeterminate structure. So we already classify these two here. Right? काय झालं? चालू आहे ना? हाँ, मला वाटलं. ओके, ठीक है. Okay, let us go with the third now. Classification of structure based on structural system. Okay, so based on structural system means here already we classify the structure in engineering mechanics, right? There statically determinate structure, statically indeterminate structure. So what is statically determinate structures? If number of unknown forces, maybe definitely external unknown forces, are greater than available equilibrium conditions, then we say it is statically indeterminate. Of course, greater than indeterminate. If they are equal to available equilibrium condition, we say it is statically determinate. Okay, so if number of unknowns are equal to available equilibrium condition, we say it is statically determinate. If number of unknowns are greater than available equilibrium condition, we say it is statically indeterminate. So already we classify these structure. Okay, so also we see the difference for that, right? So what is the difference? Example, we know this is, say, first definition we can write. If the number of unknowns are equal to available equilibrium conditions, it is statically determinate structure. If number of unknowns are greater than available equilibrium condition, it is statically indeterminate structure. What is second? You can draw the one example, any, for beam, for frame, for anything. So let us draw a simply supported beam. Simply supported beam, we know it is statically determinate. Here you can draw a fixed beam which is statically indeterminate. Okay, so static indeterminacy, already we find out 3 unknown forces, 3 equilibrium conditions, so 0. Here 6 unknown forces, 3 equilibrium conditions, so we can say it is 3. So R is greater than 3. So this is static indeterminacy of the structure. So we are going to find out this definitely in later word. Next, what about the next? How you can differentiate statically determinate and indeterminate? This is very important. Practically, statically determinate structures are very difficult to construct or very difficult to made up. So these are uneconomical. Okay, see, to prepare a roller support, it is very difficult task. So they are uneconomical. Okay, so practically all the structures, civil engineering structure, all they are statically indeterminate. Okay, so here they are economical, definitely, and safe, we can say. Of course, determinate structures are also safe, but practically they are very difficult to prepare. So that's why we say uneconomical. But indeterminate structures are easy to prepare, or we can say it is statically indeterminate or economical. Okay. और एक है very important that see statically determinate structure, first of all we analyze. Why? Because they are easy to analyze. So we can say easy for the analysis. This is under statically determinate and very not difficult, we can say. It takes the time for the analysis. So that's why we are analyzing indeterminate structure, because practically all the structures are indeterminate, with each having definitely the degree of indeterminacy. So this is the classification of structure based on structural system that we understand. Okay, also we can classify the structure based on stability. Okay, so what is mean by stability of the structure? Stability means the structure remains in position. The ability of structure to remain in position when the external forces applied on it. Okay, that ability is nothing but the stability of the structure. Okay, so we can classify this into 3 categories: stable, neutral, unstable. Stable structures, neutral structures, unstable structure. So stable, definitely they are remain in position when the external forces applied on it. So definitely they are going to deform by some amount and it regain its original shape and position, we can say. Okay, it does not changes its position. It changed by some amount, but it remains in position. So we say it is a stable structure. Okay, unstable कौन से होंगे? जो पोजीशन में नहीं रहेंगे, वो पोजीशन चेंज करेंगे, उसे हम अनस्टेबल कहेंगे. और न्यूट्रल, वो पोजीशन चेंज करेंगे और फिर रेस्ट रहेंगे, तो दोनों में आ जाएंगे वो, इसलिए वो न्यूट्रल है. तो ये है मेरे पास, आप देख लो. इफ it is defined as the ability of structure to remain in position when the load applied on it. So stable structures क्या होंगे, unstable क्या होंगे, ये देखो. These are the structure that deform elastically. So there are some deformation develop in it, and immediate elastic restraint developed under the action of external loads. So that is generally possible occur in stable structure. Unstable structure, these are the structure does not have sufficient number of internal or external restraints. So why this is happen? If the number of members are less than the available, then we can say the requirement, or number of supports are not improper, or we can say deficient than required, then we say the structure is unstable, because then and then only structure become unstable. So it will undergo movement of structure, okay, upon application of small displacement, okay, displacement. So structure may be internally unstable, it may be externally unstable. We can say it is अनस्टेबल स्ट्रक्चर. अगर स्ट्रक्चर इंटरनली भी अनस्टेबल हो तो भी हम उसे अनस्टेबल कहेंगे, एक्सटर्नली भी हो तो भी अनस्टेबल कहेंगे, अगर दोनों हो तो भी हम अनस्टेबल कहेंगे. तो अनस्टेबल स्ट्रक्चर प्रैक्टिकली नॉट पॉसिबल बिकॉज वी नीड सेफ्टी, राइट. तो स्ट्रक्चर्स, ऑल द स्ट्रक्चर्स आर स्टेबल. Okay, so practically all structures are stable. They are producing some elastic deformation, but immediate restraint is developed internally as well as externally, right. So all the structures possibly are, practically they are stable. So what about determinate, indeterminate? Determinate structures are stable, indeterminate structures are also stable because both are safe, they are remains in position, right. But deficient structures are unstable. Okay, so remember this. If number of unknown reactions are less than available equilibrium condition, E, okay, if number of unknown reactions, capital R or small r, if they are less than available equilibrium condition, then we say structure is externally unstable. Okay, and if number of members in the structure are less than available number of internal unknowns, in other words we can say the number of internal unknowns are less than available equilibrium condition, then we say structure is internally unstable. So let us see. So this is one animation available with me, so that you can see stable structure, they just deform by some amount, but it comes under their own position, or we can say immediate elastic restraint provided. So if disturbance given to this ball, it comes back to its original position due to support condition provided. So stable structure. See this, neutral equilibrium, neutral structures, they change its position and then remains in stable condition, right. So this is the example. So if disturbance given to ball, it shifts its position of equilibrium. Neutral. Unstable, तो ये unstable. अगर disturbance दिया तो definitely they are continue in the motion, they are not remains in position, right. So this is about the structure. So classification of structure we can say stable, unstable, neutral. अब देखो ये externally stable structure means what? Here they are indeterminate. So hinge supports are sufficient to carry the loads. Okay, it does not change its position. This is determinate frame. So this is also sufficient to carry the load. It does not changes its position. So externally stable. Externally unstable के example देखो. अब ये रोलर सपोर्ट है, इस बीम दोनों रोलर है, इस पे अगर हमने इंक्लाइंड फोर्स अप्लाई किया तो क्या होगा? देयर मे बी अ पॉसिबिलिटी ऑफ मूवमेंट ऑफ द स्ट्रक्चर, बीम्स मूव हो सकते हैं इधर उधर, तो अनस्टेबल है. अब यहां पे देखो, दिस इज पासिंग फ्रॉम दिस पॉइंट, रिएक्शन, दिस रिएक्शन, सॉरी ये इंक्लाइंड होना चाहिए, ये भी पासिंग हो रहा है, ये भी पासिंग हो रहा है, ऐसे तीनों एक ही पॉइंट से, अगर सब रिएक्शन अगर एक ही पॉइंट से पास हो रहे हैं तो डेफिनेटली दैट स्ट्रक्चर इज अनस्टेबल. ये ऐसे भी आप कह सकते हो, जैसे यहाँ पे भी सभी एक ही पॉइंट से पास हो रहे, ऑल आर पासिंग फ्रॉम कॉमन पॉइंट, सो वी से इट इज अनस्टेबल. एक्सटर्नली अनस्टेबल, इंटरनली अनस्टेबल के ये एग्जांपल्स है मेरे पास. ये देखो यहाँ पे डिफिशियंसी है ट्रस की, नंबर ऑफ मेंबर्स की, m should be equal to or greater than 2j minus 3. This should be satisfied, then and then structure is stable. Okay, if not then structure become unstable. तो इस केस में m is less than available equilibrium conditions 2j minus 3. ओके तो ये इसलिए इंटरनली अनस्टेबल है। यहाँ पे भी अगर ये इंटरनल पिन इक्वल एंड अपोजिट फोर्सेस डेवलप करेगा तो ये रोलर दोनों मूव हो सकते हैं ऐसे। यहाँ पे भी वही है, यहाँ पे इंटरनली अनस्टेबल है, नॉट एक्सटर्नली, इंटरनली अनस्टेबल है, क्योंकि कभी भी कोई भी ट्रस हम ट्रायंगुलर फॉर्म में ही यूज करते हैं, राइट, क्योंकि यही कंडीशन है 2j-3 आने का। ठीक है, तो कोई भी जॉइंट अगर आपको बनाना हो तो 2 मेंबर्स प्रोवाइड करने पड़ेंगे, तो ये उस पे ही ये कंडीशन डेवलप होता है, m is equal to 2j-3, right? So internally unstable structures are here. Okay, so structure may be internally unstable, externally unstable, we can say it is unstable structure. So I hope you understand this. Let us go to next point, that is the basic principles used for structural analysis. Which are they? जैसे कि डिटरमिनेट स्ट्रक्चर तो हमने ऑलरेडी एनालिसिस किया है मैकेनिक्स में, सॉम में, राइट। अभी हमको इनडिटरमिनेट स्ट्रक्चर्स का एनालिसिस करना है। क्यों? क्योंकि प्रैक्टिकली ऑल एंड ईच एंड एवरी स्ट्रक्चर इज indeterminate, so we need to analyze it, we need to study it, so that's why. So to find out the number of unknowns we need to apply some principles, okay, some methods. So these are the some principles we can say. Equilibrium conditions already we use, elasticity conditions we need to use, compatibility conditions we need to use, boundary conditions we need to use, energy conditions we need to use, right? So all these we need to use, okay, to get the equations, to solve the number of, to find the number of unknowns by using these all principles. Okay, so all the methods which are available that based on these all conditions. किसी ने energy conditions use किया तो उसे to analyze the structure, किसी ने compatibility किया, किसी ने boundary condition use किया, किसी ने elasticity किया, किसी ने equilibrium condition use किया और structure का analysis किया। इसलिए ये अलग अलग methods बने हैं, तो वो हमें study करना है। I hope you understand this lecture. Okay, so this is fundamental of structure. इसमें हमने सिर्फ classification of structure पूरा study किया, assumptions देखे, structure क्या है, structural analysis क्या है, principles क्या है। इसके बाद हम इसी पे ही जो MCQs है वो देखने वाले हैं, राइट। सो विल फोकस ऑन दैट MCQs. सो आई होप यू एंजॉय दिस. Go through next video in which all MCQs are explained shortly. So go through that video. See you for this. Bye.